Hey, calculus kids, this is Dr. Callahan with week 14 Monday. I hope you guys had a wonderful weekend. Go ahead and pause the video and answer the following 3 questions. All right, you guys, let's go ahead and just jump right into what we're doing today. So here is the breakdown of where we are. So today is week 14 Monday. And so if you look at this, you should be on unit 3 with differentiation techniques. Make sure you guys read the Princeton review book. That's on page 135, 160, 225 to 233. Pick any 30 questions for Mondays and Tuesdays for unit 3, and then move on to unit 4 right here. And here are the pages for the Princeton review. You can go ahead and for this one, pick any 20 questions because these questions are a little bit more difficult. I'm also giving you guys 3 days to do this. And so just keep in mind that both of these are due by Sunday, week 14 by 11:59 p.m. All right, so today is the 19th of April. This is week 14. You have week 15 after that, 16, 17, 18. And then week 19, Monday, is a day of the test. So after this week, gives us exactly 4 more weeks to kind of prepare for this exam, which is actually plenty of time. Traditionally, you will be taking it on the 4th of May. So that would have given us only like 1 more week. So this time around, you have several. In addition to that, make sure you are going over and 30 questions from the Albert I.O., Princeton Review. If you have not finished the math exam for week 1 at 12 or the AP College Board on Wednesdays for the assessment, make sure you are doing that. And then get yourself prepared for the 2 practice exam. They're 3 hours and 15 minutes apiece, 51 questions. The breakdown is as follows. Your actual exam on the AP College Board test on May 24th will follow this breakdown guideline. So we're just kind of preparing you to get ready for that. All right, so with that said, let's go ahead and take a look at the next question that we're going to be going over. This question is actually going to be one on volumes and area. It is the first question that was used in 2003. So go ahead and take a look at it and we'll go over it together. All right, so looking at this part right here, it's important that before you get started with this question that you kind of label the graph so you know which equation is affiliated with which. Now, you know that the square root or the parent function of a square root of x looks like this. So I'm assuming that this part right here is going to be y equals square root of x. And then the counterpart of that, which is going to be this y equals e to the negative 3x, is the blue line. And it says with the vertical line x equals what? So here is 1, and so this is x equals 1. All right, so A asks you to find the area of R. So let's go ahead and take a look at that. In order to find the area, we want to look at how this is going to be drawn. It's not necessarily rotating on anything, but if you do go ahead and draw the radius for this graph here, I will have this radius right here where it is the top minus the bottom, and you're going to look at this top minus bottom, and because it's top minus bottom, you're looking at it from the integral of x1, x2, and that's going to be 0 to 1 in this situation. And so the top of this, and everything has to be solved for y in terms of x, so, and everything else, so that works perfectly. So then I have the square root of x minus e to the negative 3x dx. And then looking at this part here, it appears that my graph actually doesn't start at 0, although I kind of made the assumption it did, but it doesn't. It actually starts right here, which is the intersection between the two lines. And so what you could do is you can set them equal to each other and then solve for x to be a little bit more specific, because I'm trying to figure out what is this location for x1. So let's go ahead and find the intersection. Your intersection is square root of x equals e to the negative 3x. And so looking at this, if you do a ln on both sides, you could go ahead and have this part cancel. Negative 3x equals ln square root of x, which actually doesn't really help you in any sense of the way because you can't get rid of that. So let's see, if I do x to the 1/2 equals e to the negative 3x, there's just no way to go about to solve this. So my suggestion is you want to go ahead and graph both of the equation into the y1 and y2, and then you push math, find the button that says intersection, and then find the intersection of these two. And in which case, the first intersection is 0.239. All right, so now that we have this, you're going to use your TI-84. Make sure you guys go ahead and push math. And make sure you do 9. Insert the lower upper bound. Make sure you put the x for the dx. Hit enter, and then your area is 0.442 unit squared. And that's your part A. Now let's take a look at part B. B says find the volume of the solid generated when R is revolving around the horizontal line y equals 1. So at y equals 1, which is right here, you have this line. So if you can imagine, you have a rectangle here. There's going to be 2 rectangles with the washer method. So here's my rectangle, and then here's my smaller rectangle like this. And it is going around this part right here, which means it is going to be a top minus bottom. And you're going to need to find r of x, which is the big radius. And that's going to be the top. And the top here is y equals 1. The bottom, remember, is going to be y equals e to the negative 3x, which is going to be, and I should color code this green line. Okay, so that's what this one is. And then this purple line right here is y equals square root of x. Keep in mind, everything has to be y equals solved in terms of x. So r of x is top minus bottom. With this big rectangle here, or the radius, you have the top, which is going to be e, or actually it's 1. So 1 minus the bottom, which is e to the negative 3x. And then you want to look for the smaller r of x, which is a smaller radius, and it's a top, which is 1, minus the bottom, which is this purple line, square root of x. So then your volume formula is going to be pi integral, and it has to be in terms of, you're looking at the integral from the y standpoint, from the x standpoint. So here, like we said before, is 0.239. This is 1, so 0.239 to 1 r of x squared minus smaller r of x squared dx. So let's plug this in. 0.239 r of x squared is going to be just 1 minus e to the negative 3x squared minus 1 minus square root of x squared dx. And again, you're going to use your TI-84 calculator, and you want to go ahead and push math 9, insert the formula, and then hit enter. You should get a 0.0453 pi unit cubed. And that is your answer for B. All right, so for C, it says the region R is the base of the solid. For this solid, cross section is perpendicular to the x-axis, and it is a rectangle whose height is 5 times the length of its base in R. Find the volume of the solid. So this is the one we're going to use the cross section instead. So if this cross section is perpendicular to the x-axis, and you know that this is the x-axis, perpendicular means that your radius is going to be vertical. And if your radius is going to be vertical, then your integral is going to be from x1 to x2. Everything has to be solved for y in terms of x, and it's a top minus bottom. In addition to that, remember you need to find the base of the rectangle. So here is your base, or here's your rectangle. And the base is going to be a top minus bottom. Your top here is y equals square root of x. Your bottom is y equals e to the negative 3x. So top minus bottom is square root of x minus e to the negative 3x. That's your base, which also means that the base for this rectangle is going to be square root of x minus e to the negative 3x. Whose height is 5 times the length of its base. So with that hint, you know that the height right here is going to be 5 times square root of x minus negative e to the negative 3x. All right, so now let's take a look at the area, okay, of the cross section. Your area is going to be base times height for a rectangle. So then base, which is square root of x minus e to the negative 3x, times height squared. Now that you have your area, let's talk about volume. Your volume is going to be the integral with the area of the cross section, which in this case is a rectangle that we just found, dx. All right, so let's plug this in. Volume equals integral 0.239 to 1. Area of the cross section is going to be 5 times the square root of x minus e to the negative 3x squared dx. Plug this into your calculator. Once again, math 9. Make sure you have the upper and lower bound, the equation inserted correctly with the x for the dx. Now hit enter, and then your answer should be a point or 1.554 unit cubed. All right, you guys, so now that we've completed this, what I want you guys to take a look at is the grade breakdown. It's 1, 2, 3, so it's 9 points. It seems like this is what they do with all the questions. They just generally seem to have 9 points. So from there, I want you guys to go ahead and take a look at this piece here. What this is, oops, right here. What this is the 2003 scoring commentary. It kind of breaks down why they picked the graph, or why they picked the question, what is it requiring you to do, what the average score was. And so take a look at how this is done. And it also tells you the breakdown, how it's scored. Next, what I'm gonna have you guys do is, with this QR code or this link, go ahead and type that in. You are going to grade 3 students' work aligned to the grading scale breakdown, and let me show you where you go with that. So once you type this link in, it's gonna look something like this. And you wanna go down to 2003, and actually this gives you all of the free response up to 2018. So you go to 2003, so free response question. You're gonna go to sample response 1, because that's the first question on the test. And then it's going to take you to this page here. And what I want you to do is find 3 students' work, and then take a look at what they have and how they scored, or excuse me, what they wrote down for the scoring itself with this question. It's important to know how other students are answering this question because you guys can be doing the same thing. So you can scroll down, take a look how it's answered, take a look how what they wrote down for it. And specifically, you're just going to be looking at the first question here for 1. You don't need to go down to 2 or anything, so just 1 to see. Okay. If you want to look at some of the other questions that are also responded to, you can go ahead and click on those as well. Okay, so then next, what I want you guys to do is take a look at the back of this. So this one is the commentary for the AP Calculus exam. And it kind of breaks down specific questions like what was the intent of the question? How well did students perform the question? What were the common student errors? And this part right here is probably the most important part, so that way you can avoid it. Based on the experience of the students' response, what messaging would you like to send to students that might help improve performance on the exam? One of the things that they did not need to compute the antiderivative to compute the definite integral. You should be able to use a calculator, obviously, and that's why I'm teaching you guys how to use a calculator, which is really important. And then also, if you take a look at this is kind of like how each of the questions broken down with the scoring. The average score is a 3.9. Uh-oh, let's see what happened here. Let's try that again. The average score here is a 3.9 out of 9. So obviously that's a fairly low score, but you can still pass with that. And then next, what I would like you guys to take a look at is pick another free response from the list, analyze how the questions were graded, explore the resources available because you have all of the free response questions available to you since 2018. All right, you guys, if you feel like you are confident enough, what I would like you guys to do is turn over to this page in your guided notes for week 14 Monday. I actually have several other questions here that you can explore, and the link to the video showing you how to do this is right here on this link. Well, I hope you guys have a wonderful week, and as always, stay safe and healthy. I'll see you guys next time. Take care.